Article 110.14 addresses connections involving dissimilar metals. This article mandates that all connections involving dissimilar metals, whether they are current carrying or not, must utilize a listed wiring device. Examples of listed wiring devices include wire connectors, commonly referred to as wire nuts, or solderless connectors. The primary reason for this requirement is to mitigate the potential for galvanic action. Galvanic action is a type of corrosion that can occur when two dissimilar metals come into contact in the presence of an electrolyte. An electrolyte is a substance that conducts electricity, and in electrical systems, moisture can often serve as the electrolyte. The presence of moisture bridges the gap, setting the stage for a chemical reaction. The less noble metal will corrode preferentially, sacrificing itself to protect the more noble metal. This corrosion can weaken the connection, leading to increased resistance, overheating, and potentially a complete failure of the electrical circuit. Even in non-current carrying conductors such as grounding electrode conductors, or GECs, galvanic action can still occur. While the absence of electrical current reduces the likelihood of galvanic corrosion, it doesn't eliminate it entirely. The presence of moisture alone can act as the electrolyte, facilitating the corrosive process between dissimilar metals. Therefore, the best practice is to adhere to the requirements of Article 110.14 and use a listed wiring device to join dissimilar metals, regardless of whether they carry current. Now let's turn to the specific situation of using aluminum wires with ground screws. The National Electrical Code, or NEC, does not explicitly forbid the direct connection of aluminum wires to ground screws. However, there are important considerations to keep in mind when making this type of connection. Aluminum wires are generally more prone to corrosion than copper wires. This increased susceptibility to corrosion stems from the properties of aluminum itself. When exposed to air, aluminum readily forms a thin layer of aluminum oxide on its surface. This oxide layer is actually quite protective, preventing further corrosion under normal circumstances. However, in the presence of moisture and dissimilar metals, this protective layer can break down, leaving the aluminum vulnerable to galvanic corrosion. Given the potential for corrosion, especially in environments where moisture is present, it is generally recommended to use a copper pigtail when connecting an aluminum wire to a ground screw. A copper pigtail is a short length of copper wire that is used as an intermediary between the aluminum wire and the ground screw. Firstly, the aluminum wire is connected to the copper pigtail using a listed wiring device that is specifically designed for joining aluminum and copper conductors. Secondly, the copper pigtail is then connected to the ground screw. This approach offers several advantages. Using the copper pigtail isolates the aluminum wire from direct contact with the ground screw, reducing the risk of galvanic corrosion. The listed connector creates a secure and reliable connection between the aluminum and copper conductors. The copper pigtail provides a more corrosion-resistant connection to the ground screw. In summary, while the NEC does not explicitly prohibit the use of aluminum wires with ground screws, it is prudent to exercise caution and take measures to mitigate the risk of corrosion. Using a copper pigtail in conjunction with a listed connector is a recommended practice for ensuring a reliable and long-lasting connection. Adhering to the requirements of Article 110.14 and employing best practices for connecting dissimilar metals will contribute to the overall safety and reliability of electrical systems. When working with electrical systems, always consult the latest edition of the NEC and follow the manufacturer's instructions for all equipment and materials. Now let's delve deeper into the specifics of galvanic corrosion. Galvanic corrosion is an electrochemical process that occurs when two dissimilar metals are in electrical contact in the presence of an electrolyte. The electrolyte provides a medium for the flow of ions, which facilitates the transfer of electrons between the metals. The metal with a higher electrochemical potential, which is less noble, will corrode preferentially, while the metal with the lower electrochemical potential, which is more noble, will be protected. The rate of corrosion depends on several factors, including the difference in electrochemical potential between the metals, the type of electrolyte, the temperature, and the surface area of the metals in contact. In electrical systems, common examples of dissimilar metal combinations include aluminum and copper, steel and copper, and zinc and steel. Aluminum and copper are frequently used as conductors, while steel and zinc are often used for enclosures, conduits, and hardware. Moisture is the most common electrolyte found in electrical systems. Moisture can enter electrical systems through condensation, leaks, or direct exposure to the elements. The presence of salts or other contaminants in the moisture can increase its conductivity and accelerate the rate of corrosion. To prevent galvanic corrosion, it is essential to select compatible metals for electrical connections. Metals with similar electrochemical potentials are less likely to corrode when in contact. When dissimilar metals must be used, it is important to isolate them from each other to prevent electrical contact. This can be achieved by using insulating materials such as tape, coatings, or washers. Listed wiring devices, such as wire connectors and solderless connectors, are designed to provide a secure and corrosion-resistant connection between dissimilar metals. These connectors typically feature a barrier that prevents direct contact between the metals. They also contain a corrosion inhibitor that helps to protect the metals from corrosion. Ground screws are typically made of steel or brass. When connecting aluminum wires to ground screws, it is important to use a connector that is specifically listed for use with aluminum and steel or brass. These connectors typically have a coating that prevents galvanic corrosion. In addition to using listed wiring devices, it is also important to protect electrical connections from moisture. This can be achieved by using weatherproof enclosures, sealing connectors with silicone caulk, or applying a corrosion-resistant coating to the connections. Regular inspections of electrical connections can help to identify and address potential corrosion problems before they become serious. Look for signs of corrosion, such as discoloration, pitting, or flaking of the metal. If corrosion is detected, clean the affected area and apply a corrosion inhibitor. In severe cases, it may be necessary to replace the corroded components. Understanding the principles of galvanic corrosion and implementing appropriate prevention measures can help to ensure the safety and reliability of electrical systems. Remember to always consult the latest edition of the NEC and follow the manufacturer's instructions for all equipment and materials. It's also important to consider the specific environmental conditions in which the electrical system will be operating. In humid or corrosive environments, it may be necessary to take additional precautions to protect against galvanic corrosion. This could involve using more corrosion-resistant materials, applying protective coatings, or implementing a regular maintenance program to inspect and clean electrical connections. Now let's talk about the specific requirements of Article 110.14 in the NEC. Article 110.14 covers the general requirements for electrical connections. It states that connections shall be made so that the electrical continuity will be maintained without the use of solder. The reason for this is that solder can melt under high temperatures, which could lead to a loose connection and a potential fire hazard. The connections must also be suitable for the material of the conductor and must be properly installed and used. Article 110.14b covers the requirements for splices. It states that conductors shall be spliced or joined with splicing devices identified for the use. This means that the splicing devices must be listed by a recognized testing laboratory, such as Underwriters Laboratories, or all, and must be suitable for the type of conductors being spliced. Article 110.14c covers the requirements for the tightness of connections. It states that all connections shall be taut to the manufacturer's specifications. This is important to ensure that the connections are tight enough to provide good electrical contact, but not so tight that they damage the conductors or the connectors. Article 110.14d covers the requirements for the use of dissimilar metals. This is the section that is most relevant to the question about galvanic corrosion. It states that where dissimilar metals are joined, the connection shall be made with a connector identified for the purpose. This means that the connector must be listed for use with the specific combination of dissimilar metals being joined. For example, if you are connecting an aluminum conductor to a copper conductor, you must use a connector that is listed for use with aluminum and copper. These connectors typically have a barrier that prevents direct contact between the metals and contain a corrosion inhibitor. Article 110.14e covers the requirements for the installation of conductors with different temperature ratings. It states that where conductors with different temperature ratings are installed in the same raceway, the ampacity of the conductor shall be based on the lowest temperature rating of any conductor in the raceway. This is to prevent the conductors with the lower temperature rating from overheating. Article 110.14f covers the requirements for the use of insulated conductors in parallel. It states that insulated conductors in sizes 1/0 and larger shall be permitted to be run in parallel. However, all of the conductors in parallel must be the same length, the same conductor material, the same size, the same insulation type, and be terminated in the same manner. Article 110.14g covers the requirements for the use of compact conductors. Compact conductors are conductors that have been compressed to reduce their overall diameter. This allows for more conductors to be installed in a given raceway. However, compact conductors require special connectors that are listed for use with compact conductors. By following the requirements of Article 110.14, you can help to ensure that electrical connections are made safely and reliably. Remember to always consult the latest edition of the NEC and follow the manufacturer's instructions for all equipment and materials. Now to reiterate some key points. Firstly, always use listed wiring devices for connecting to similar metals, regardless of whether they are current carrying or not. Secondly, consider using a copper pigtail when connecting aluminum wires to ground screws. Thirdly, protect electrical connections from moisture and corrosion. Fourthly, regularly inspect electrical connections for signs of corrosion. And fifthly, consult the NEC and follow the manufacturer's instructions for all equipment and materials. These practices will help to prevent galvanic corrosion and ensure the safety and reliability of electrical systems. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself from injury. If you are not comfortable working with electricity, it is best to hire a qualified electrician.